Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Qualcomm Oryon CPU. So let's dive deep into it. Now, be mindful that technical specification is not important, but the change that it is causing is very important. So we have to understand the context behind it. Context is there is a company known as ARM Holding. Now they design a RISC-based CPU. What is RISC? RISC is reduced instruction set computer. Now you have to understand this in the early days, as just after the Apollo era, computers were being made. But here's the deal. RAM was not a thing. You and I, we live in a very healthy world where we do not worry about RAM. Like your fridge could have like 2 gigabytes of RAM. But the early computers, when they were started, kilobytes were a luxury. It's like, whoa, kilobytes of RAM. Damn. So in that era, they had to design CPU according to that limitation. So they created a complex instruction set architecture. Inherently, it's a much more efficient system if you just do not have RAM. However, just a few years after that, like you can look into the Google and timeline and all that jazz, RISC was created. And I'm like, was the RAM problem solved? Not really. However, there was a need felt that we should have something simpler for simpler things. Meaning, if you want to automate your microwave, you do not need to run 10,000 calculation. You may require something simple. At that point, even that low amount of RAM will be more than good enough. However, brick by brick, day by day, things changed. The RAM became plentiful. The moment that happened, RISC started to spread out its wing. And because of the simplified structure, inherently it's far more energy efficient, especially if you can make RAM itself energy efficient, which we did. And eventually, this puppy grew wings and started to fly faster than x86. Now, Qualcomm buys ARM designs from ARM Holdings. So whenever you hear in basically CPU, basically SoC breakdown, you hear like Cortex A15 or Cortex A17 or whatever have you. That's a design that is bought from ARM Holdings. Now, ARM Holdings makes the core architecture. Now, ARM Holdings is a very clever company. What they do is like they don't actually make the stuff themselves. Their core focus is we're gonna design it, we're gonna build it, develop it, test it, bug fix it, do all the driver modifications, and then we're gonna sell it. And whoever wants to buy it, they can go YOLO on it. It's not like x86 where there is only two companies. This is like you have the money, take it and go. So what Qualcomm does is basically takes the design from ARM and then they apply special sauce. Now this special sauce is the main key. So you take the CPU, apply special sauce to it, and that's what makes your SoC. Whenever you see Samsung Exynos, whenever you see MediaTek Dimensity, whenever you see Snapdragon, what are these? These are SoC. They have the CPU, but they have special sauce. Now this special sauce is the key, because you can understand that like if Apple is buying the same thing, Samsung is buying the same thing, MediaTek is buying the same thing, Huawei is buying the same thing, why the heck their performance are so different? It's the special sauce, how they are arranged, how they are cached, how like there is a surprisingly large amount of sauce goes into it, even though the core design starts from here. Because packaging, again, if you have proper packaging, your RAM will be like GG. RAM in this scenario would be cache memory. If you have really good cache flow, if you don't, even you could literally have a next generation CPU, it will not perform well. So fundamentally, this is what we are talking about. So somewhere along the special sauce, Snapdragon created even more special sauce. So this is what changed. ARM is same, everybody else is same. What special sauce Snapdragon did, it allowed their SoC to stand above the rest. So let's compare it to Apple. Now, Apple did the impossible a few years ago, is that they actually switched a laptop from x86 to RISC system, as in their own in-house M1 series ARM, where they took design from ARM, applied special sauce. So this is special sauce of them, and then they made this puppy. It worked. Now, how the heck they figured it out? Well, they realized very early. This they were more clever rather than smart. They were very clever. It's just that it's one of those things that everybody's like, what do you want in your computer? Oh, I want like 10,000 computation performance. It's like, what the hell you gonna do on it? I'm gonna watch YouTube video. It's one of those things. Apple did had enough data to realize that if they are making a very thin and light, if it can type document, if it can watch videos, if it can do light computation task, it's more than good enough. Like people good. And if you can give big battery life, people are like, shut up, take money. So they took a leap of faith. Now, how the heck they can pull it off compared to everybody else? Neither HP did it, nor Dell did it, nor Lenovo did it, nor Microsoft did it. It's simply because they have vertical integration. Meaning, when they basically jumped from x86 of Intel to ARM holding designs, they had the control over drivers and OS system itself. So there are three things: you have hardware, you have drivers, and you have operating system. Because your application, whatever application it may be, let's say Final Cut does not directly talk to the GPU. It talks to the driver, asks the driver, hey, I need this. Driver's job is like, okay, which GPU I have? Okay, that's the GPU. This is how I talk to you. This is how you crunch the data. You give it to me. That's why, like, once you install a GPU in your computer, you install the driver. So because Apple had control of all these three levels, they could pull it off compared to Microsoft. Microsoft, even if they had control of operating system and driver level, they had zero control over basically hardware. So that's why Apple pulled it off, and it worked. Once people realized a fanless laptop had so much horsepower, which, mind you, it's not that much horsepower, it was just clever. And again, even your Snapdragon of the similar time, if they had given wings, it would have sort of performance. But they were very clever. I had to give it, like, they were very clever. Not too much, not too little, clever. So they did it, and consequence of that was laptop became cool, because it was like, hey, laptop had become something where people have forgotten about it. It's like, I had to carry a laptop, so I have a laptop. But this made laptop cool again. It was like, oh, it's a new hip device that has a unique property, aka huge ass battery life. So it made it cool again. Now what Qualcomm did is like, hey, what if this huge ass battery life is something that Windows can experience, if this is something that Chromebook can experience? The moment that happens, the equation changes. Now Chrome OS is far more important here, because if Qualcomm wants to work with Google, and Google wants to work with any of their partner, Google will have much smoother time getting the driver things working, OS things working for their Chrome OS, compared to Microsoft, Qualcomm, then a device vendor. So because be mindful, that's exactly how all Android phones are done. So that pipeline, like phone going from Qualcomm to Google to basically the device vendor, that's already happening. So this is a very significant boost to Chrome OS devices, meaning in next 2-3 years, we'll have Chrome OS devices which will have same polish, same efficiency, even better battery life than Apple. Now you'll be like, what if they do not have the software polish? Well, here's the deal. There is two ways of taking care of something. A, you polish the hell out of it. Like how the heck Apple was so smooth in the early days when they had so little RAM. They polished the hell out of it. So how do you compensate for it? Well, give a big ass RAM. Same here. If your CPU is not as optimized code like compared to like Apple, you just give more horsepower. Like single threaded performance, if your performance is more enough, you're like, okay, yeah, my application is not running efficiently, but my horsepower is so high, we can brute force it to solve. So that's why this 30% less power consumption, 70% compared to x86 design, that is why it's so significant. If they can beat M2 Mac processor, and they're like, hey, we are still consuming 30% less, that simply means they have headroom. That headroom allows them, that's like, hey, we're gonna give you same battery life and same feel, even though our actual code is less efficient, even though the apps and all that jazz is less efficient, because we can run it far harder. It's like a more fuel efficient car, so to say. So it's a very big whoa to Apple. It's like, trust me when I say this, it's not just like, who cares? It's like, whoa, 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 pump the brakes, kid. Like, this is significant, especially if that M2 part is. And people are suggesting that it's actually horrifyingly close to M3. If that is true, Apple is like, yeah. So that's one of those things. Then we come to x86. Now, x86 had some rough years. That rough year started from 2010. I'm just simplifying. You can Google and time frame and all that jazz. It's just that Intel reached a stuck phase, and this meme started to happen. It's like 14 nanometer, 14 nanometer plus, 14 nanometer plus plus, 14 nanometer plus 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 plus. This is the same meme happened. And during this time, AMD was also creating horribly bad processor. Ask me how I know, because this was my second CPU, FX Bulldozer. Good painful times. But that was the whole point. Like that era, you had horrible power consumption, like literally very incremental growth. Like growth was like, now, and what is that year? 2010. That's when smartphone really start to get going. And that time, ARM is going from whoa to like, holy damn, to like, oh my god, like bam, 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 upgrades happening. Why it's happening? Because so many companies buying ARM designs. They are buying ARM designs, they are making their own magic sauce, and they're putting it out there. and you run this cycle 2 or 3 times, ARM Holdings gets boatload of money, and every other manufacturer become more efficient at polishing their stuff, learning from each other, and voila, ARM is getting through exponential growth during this time. And something bad happened. What is this something bad happened? While ARM was growing and everybody was aware of it, there was an ecosystem that is the backbone of our world, that is server ecosystem. Server was like x86, bro. However, servers changed, and one of the big giant, as in like huge giant, is something you may have heard of, Amazon Web Services. Yeah, they just yeet out of x86. They're like, yeah, we're gonna make our own system. They literally bought a company and made their own SoC, which is Alpine, ANNAPURNAL, Alpine Labs, which is like this. And yes, it's a company of Amazon Amazon company, and they bought design from ARM, and they applied special sauce, and this is actual stuff that is running the actual Amazon Web Services. And because Amazon Web Services are huge, they had like such a good iteration where they made the CPU, ran it next to x86, figured out all the bugs, solved all the problems, created the second iteration. And because they had such a large data set that they kept doing it, right now, if I'm not mistaken, they're on the 3rd iteration or 4th iteration. It's damn good. They're like, we are not touching x86 again. So that was big blow. Then we had another small blow company, known as Ampere. Ampere also started to, what if you had a system and it's running on ARM. Now, does that matter? Yes, RAM is cheap, power is not. So you put a lot of RAM, you run x86, and these puppies could have like 128 cores. So they're like, parallelize it, optimize it, done, good, go home. So they started to make a company. There is another company, Thunder X2, which is from Cavium, that's there. So these are just 3, and be mindful, there are many, many more, because ARM is allowed to sell to other people. Intel can't do that, because even though Intel made x86, there was a contract requirement from, I think, if I'm not mistaken, IBM, where they were like, hey, we're not going to buy from you, because yes, there was a long ago era where Intel was a small startup. So the company like huge, like IBM, they were like, yeah, you cool, bro, but we need reliability in terms of our supply chain. So you do need to contract it out to someone else. So AMD was chosen as a second backup. So that's why x86 license is only available to do these 2 puppy, while ARM had the luxury of going lol. Anybody who wants to take a Raspberry Pi wants to take it and go. If some Chinese company want to take it and go. If Taiwanese companies want to take it and go. Indian company wants to take it and go. Whoever are willing to pay, take it and go. So exponential growth happened. And Apple also ditched x86 in 2020. So that was a big oops. Now, x86 is one of those things that every developer is writing codes for it. Like, there's a lot of horsepower that goes behind the scene that you and I do not see, that is working on the back end of things. If those people start to see, wait a minute, you are not as hot, that has a what we classify as cascade failure effect. So that was a big oops. And ARM cores have reached a point where their performance to watt ratio is horrifyingly good. Meaning, if I give you a battery bank that is 100 watt hour, how much oomph, how much crunch you can do, it would be higher. Like, you maybe you have a scenario where x86 can do it faster, but all the time, like, if unit is limited, meaning you have this amount of energy, 1 unit of energy, you will always find that x86 will be left behind compared to ARM's holdings. And ARM holding had that luxury, and servers have become expensive. Why? Power is expensive. Even more expensive is the cooling that they require. So for that reason, people are like, shut up, take money if you can give me performance per watt. And that's the biggest edge of RISC architecture, reduced instruction. It's inherently simpler on a fundamental level. So x86 is in rough spot. Let's just be damn clear about it. The last few years, they have started to gain back steam, but yeah, it's not good. Not good. Like, the power draw, the fact that we have Intel CPUs whose power draw is measured in 300 watts, and this is not a CPU made for servers. This is like desktop grade. Yeah, that's not good compared to other things where your server grade barely touching 200 watts, barely. So you see, there is a very huge problem with this. Then we come to Microsoft, and now Microsoft is also under threat, simply because they have, like, more and more people are realizing that Microsoft has let themselves go, where they're like, Windows OS used to had a lot of people working behind it, like lot of effort, lot of polish was went into it. That polish is gone. like flat out. Even the people who used to work there, yeah, we used to have like hundreds of computers. That was like whole floor of a building was like just for testing. That is like, eat, we'll just launch a crappy software and then people will bug fix it for us. Like people have become beta testers, so to say, or alpha tester in some scenario. So they have decided to let it go. Now that's bad. That's dumb. Why? It's not dumb in short term. It's hyper dumb in long term. If that happens long enough, you will lose all your money, because majority, while it is true, majority of the money is coming from other services like Azure. Azure is a alternate to Amazon Web Services. It is good. It's awesome. But there is also another player that pays boatload of money, which is your office suites, meaning basically Word, Excel. Now, there is a lot of competition in that. You have document in Google and you have sheets in Google Sheets. That's horrifyingly scary. In that sort of ecosystem, if your operating system itself becomes a weak link, you could again trigger a cascade failure. So Microsoft is reached a point where they're like not looked out fondly, because again, XP was like, holy damn, this is smooth, efficient, elegant. Then we had Vista. Again, like it had good core, but execution, it was just like, sometimes people say it was way ahead of its curve, whatever have you, but outcome was bad. Then we had Windows 7, which was good. Then we had Windows 10, pardon me, Windows 8, which was like, what the hell? Then we had Windows 8.1, which was like, what the heck? Then we had Windows 10, it was like, okay, some level of semblance. And then we had Windows 11, which literally launched, claim we're gonna run Android. I have, no, it's not there. It's the same thing. Like they have just decided, they just say things and they just let it go. It's like, who cares? That is creating a very serious stress. On top of that, in India specifically, as people are getting richer, they are jumping from Windows ecosystem to Apple ecosystem. Again, there is an aspect of like, especially for video editors, there is some genuine reason. For other people, it's like to show mine is bigger than yours. So Apple ecosystem is becoming more attractive. So Microsoft really need to get their act together very quickly. On top of that, the biggest threat Microsoft faces right now is that students and kids have been firing missiles. Like there was this company known as Google. They realized how the heck Apple became so successful in computer, desktop specifically, not iPhone, desktop. They were firing missiles at education sector. So what did Google do? Took a missile and we called it laptop, and they find the cheapest laptop. Then they find the Linux system, cheapify it the hell out of it, as in like the operating system, put controls and safety measures behind it in terms of remote locking, in terms of remote management and all that jazz, and they just gave it to teachers. This is cheap stuff. Use it. It was hyper garbage at day one, but again, you are giving it to children. It was like, okay, more than good enough. Day one, day two, iteration after iteration. So that students and kid crowd, they slowly starting to go to from basically Apple, most people could not afford, wouldn't want to afford, to Windows, to, hey, Chrome. Everybody has the standard thing. And after a pandemic, it was like, whoa, 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 what do you mean? Like everybody has Chrome OS now. So that became a very big thing. And their hardware, it's getting good. Like it started with like, oh lol, to like, whoa, whoa, what do you mean? This is an actually competent laptop that can actually do some serious work. How the heck that happened? It happened because Google figured out where to fire the missile. They were very clever about it. And the fact that they have learned from best of both worlds. They have learned the openness benefit of Microsoft, and they have learned the it just works from Apple. And they're like, hey, 7-year updates. Yay. So they have learned a lot, and they are making serious improvements fast enough where they're like, whoa, and all they have to do is keep ahead of the children who are just coming out of it. If children are coming out of it and they're like, hey, we have a better Chromebook, which I already know how to use, this is just more oomph in that versus a new ecosystem that I have to learn, more people will go to Chrome. So yeah, there is some serious threat to, Microsoft, like serious threat. And then we have to understand this. Somebody in Microsoft understood this part. Somebody understood it well enough that we cannot have our reputation turned to lol. So they developed an ecosystem of Surface lineups. Now Surface lineup, this one, when it came out, I was like, some artist sat down, some mechanical engineer sat down, and they were given blank check, like go lol. Like this is an amazing masterpiece. But I think it was done way too, unbalanced way. Meaning the CPU, the main thing, that was outdated when it came out. It was literally generational old when it came out. It was hyper expensive device. People would not worry, like look into the price of a Qualcomm tablet. This is free comparatively. So why didn't this sell too much? Well, the processor was outdated, like the core was outdated. And because they took the bad lesson from Apple, they were like, what if this is locked? What if we created e-waste? Yeah. If they would have made this into just a monitor that works with just a touchscreen, exactly like Qualcomm, they would have been like, hey, we have a low power computer. Again, they don't say it's a low power computer. They're like, hey, we have a computer. Hey, if you have an even better computer, connect it. But they are like, what if we created e-waste? So that's why you do not hear about this anymore. It was genuinely good. Let that be very clear. Genuinely good. But it's just like, I think they made the computer and they're like, engineers are like, here's a blank check. Make me awesome. They make awesome, but they came back after 2 years and computer guys are like, sorry, it's outdated now. But they're like, no, we actually gave them the blank check, so you have to launch it. Even this, like, I genuinely hate the fact that whoever makes the tablet and things like this, they're like, what if we give micro SD card? I hate that from bottom of my heart. Whoever engineer is responsible for that, I hate you. Like, give me UHS-2 full-size SD card slot. It's reliable, robust, fast enough. Don't give me micro SD card. You have space, and I have seen teardowns. There is physical empty space. So Surface lineup have poor consistency, meaning their hardware goes from, oh, this is good, it's like actually latest, actually useful, to like, wait a minute, I'm paying this much more and I'm getting this much outdated devices. So the yield rate is just not good. And Microsoft is not hammering this. Like, they were not like year after year after year how Chromebooks were going through, like one bam, 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 bam to keep polishing it. They're not getting it polished, and it's like, it may be a good launch, it may be a sloppy launch, it will just fade away. And they did try to make ARM OS, and they did try to make ARM SoC, which was Microsoft SQ1, specifically designed for them. Yeah, even they got bored of it. So Microsoft is in serious trouble right now from Chrome OS, and the fact that Qualcomm has some serious help, because again, it's much easier for Qualcomm to work with Google and with device vendors to make a device. Why? That's exactly how smartphones are made. So what we can expect in the future? Well, the game is on. Let that be very clear. Everybody is on their A game now. We are getting some serious excitement here. Because if this puppy, M3, which has 25 billion transistors, to M3 Max, which has 92 billion transistors, if this puppy has any performance that is even approaching these things, even M3, yeah, that would be seriously shocking to Apple. Because Apple does require a bit of aura, and be mindful, if kids are jumping from Chrome to Chrome while getting performance that is equal to Apple, it's hard to bring them back, like almost impossible to bring them back. So Apple has to go balls to the wall, like they have to go all in. They have to make sure this is good. If this is not good, they have to make sure their M4 is genuinely so ahead that the next iteration of Oryon CPUs are just, they cannot compete. Like, they have to go all out. They cannot be like, we good, you know, we are just chilling, we are so ahead. No. You're gonna be like, whew. So they really have to go all in. Like, they no longer have the edge. Then we come to Microsoft. They really need to get this stuff sorted, because if they do not polish the ARM variant of Windows OS, yeah, no. Qualcomm will try. They will give their best. But if they have two customers and like Microsoft is like, I don't give a damn, and Google is like, allow me, sir, to take care of your stuff, who do you think will get a better laptop? Same hardware. Who do you think will get better laptop? So they really need to sort this part out. Like, they have to bite the bullet and they have to pay money like there is no tomorrow, and only then they could be staying in the future, because they really are not taking how big of a threat to their Microsoft Office division is that Google Office Suite is, which is free, and Chrome OS. So they could literally go from $2 trillion company to there used to be a company. So this is significant. And then we have to understand this part. Intel really needs to gain back the 10 years they were trolling. Like, of course, there was some genuine issue, but there were also some incompetency. There was like, bro, you're actually not trying. There was like flat out those periods. They were like, are you actually trying to make a good CPU, or you're just like, just increase a little bit. It's just like, every time it's just like, more hertz. It's like, dude, are you improving the clock efficiency? So Intel really needs to pay back for that comfortable era, so to say. And AMD has to change their gear. They cannot be like, we are more energy efficient than Intel. While it is a good strategy, it did work, it did allow them to make sure the next generations of servers that are being built, because again, energy is the most expensive part, because you pay for it twice. You pay for the bill and you pay for double of that amount for the cooling part. So it's in your best interest to actually make sure that you get an efficient system. That is paying out now. Like they're slowly starting to chip away from x86 server market. That's good, that's awesome, but they need next gen target. The next gen target is not Intel, it has to be ARM. They have to make sure by the Ryzen, I have Ryzen 5000, by Ryzen 7 or 8000 they should have something that should be comparable to ARM, as in x86 complex instruction set architecture should be compatible with, not compatible as in like should be competent enough where it can go toe to toe in performance per watt to a RISC system. If they do not, they are in serious trouble, same as Intel. And x86 as a whole, as in Intel and AMD, has to get in a room together and make love and figure out how to make sure that this issue is solved. Because SoC is a complete unit, and if a SoC that's like actually is much tinier than that, if that can run a whole laptop, you do not need NVIDIA GPU, AMD GPU. You do not need that. You do not need an extra computation unit just for neural network calculation. It has hexagon neural processing unit, AI unit basically. So they have to get in bed together. They have to make sure some coherent thing is made into x86 where they're like, hey, this could be, there are certain things like that for cryptographic acceleration on server end. They have to bring something like that into a desktop ecosystem. x86 needs to improve. So Intel itself is in problem, AMD itself is in process, and they both of them have to put some of their competition aside, get in the bed together with x86 and make x86 new again. And then we have to understand the biggest risk right now is the ARM. So far, everybody is talking how the heck Qualcomm did it, how the heck Apple did it. Nobody is talking about basically ARM. Why? Well, ARM is going from like we designed the 99% of the things to like we are just giving you a building block. Like that is scary from ARM's point of view, because if ARM does not keep innovating exponentially so, they will reach a point where all the manufacturers, be it Apple, be it Qualcomm, they would be like, we are paying you boatload of money. Your structure is RISC. Awesome. We cannot jump to x86. Okay. But there is another RISC in town, which is RISC-V, which is free. We can just jump into it. If our special sauce is what takes it to make it really that good, what if we push extra bit? Now, would first generation RISC-V based CPU would be as good as this one? Hell no. But it would be competent enough. It would be good enough where it can just push through the first generation hurdle. And if 2 or 3 generation goes by, ARM holdings could be like, poof, gone with the wind. So this is a very significant thing. ARM must improve, otherwise like RISC-V will be like, and be mindful, RISC-V penetration is slowly itching away. Right now, we literally have microcontrollers that are coming out of RISC-V, like literally, and there are NVMe SSDs whose controller is RISC-V. Brick by brick, day by day, and there are like point of sale devices, things of this nature. They're like chipping away, exactly how ARM chipped away at old era x86. So RISC-V is chipping away. So ARM is also under a lot of stress. And Qualcomm must get a good hardware system. That is the biggest hassle with Qualcomm. Like Qualcomm, like this is amazing, but Windows team would be like, yeah, put it there. We'll launch it like 5 years from now. And versus Chrome OS, that's why I'm far more excited about Chrome part, where they're like, get that CPU, get hardware vendors, get it now. They'll be like, damn. It will be like put next to a MacBook and people won't even notice it, like, this is efficient, this just works. So people, because again, Chrome OS does have that ecosystem. It's like, it just works. It does have updates. It does have security updates. So there is, this is the first time that we are seeing so much shock and awe going on all at the same time, where Apple is like, yeah, the illusion is wearing off. We really need to apply the gear again. Microsoft is like, yeah, if we keep ignoring, we will go away from 2 trillion. We may spike to 3 trillion, and that will be the final, and then like, so they really need to get their stuff sorted. Intel, now they're gonna suffer for that 14 plus. AMD, again, they have made a good recovery, but they really need to aim up much higher. They cannot be aiming to CISC architecture level. They have to aim to a RISC architecture level. x86 itself, unless AMD and Intel can get in bed together, x86 is not becoming better. And ARMs, they really need to up their game, because RISC-V is literally chopping at it already. Qualcomm, that's the most saddest part for them. It's like, we could make amazing Windows laptop if only Microsoft has sorted that part. So I'm pretty sure they're gonna make this slowly gonna fade away from Windows to Chrome. So this was my presentation on basically the biggest announcement of recent times, Qualcomm's new CPU. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.